Hello class. Today our topic of discussion is exponent or indices is the same thing. First of all, we should have a clear idea what is exponent. Now an exponent or index is a number which indicates how many times another number, the base is being used as a repeated factor. Now what does it mean in simple term? Suppose you have x to the power n. Then over here n represents index and x is your base, and x to the power n means x is repeated n times, which means x multiplied by x multiplied by x. How many times? N times. For example, you have 2 to the power 5, so 2 multiplied by 2 multiplied by 2 multiplied by 2 multiplied by 2. How many times? 5 times. Over here 5 is your exponent or index and 2 is your base. We should know that your index is always a positive integer, because of course if I write 2 to the power minus 5, can you repeat 2 minus 5 times? Not possible. So your index is a positive integer and n is greater than 1, because we know x to the power 1 is x. Hence n is greater than 1 and n is always a positive integer. Now we look at some properties or laws on indices. Okay. Now look at the properties of exponent or the laws. The first one, the product of two real numbers represented with an exponent and having the same base. In that case, what we do? We simply add the exponent or the power and the base remains the same. What I mean? Suppose 2 to the power 5 multiplied by 2 to the power 6 simply becomes 2 to the power 11. Of course, over here your A belongs to real number and M and N are positive integer. Done. Next case, in case of division, if the bases are same, you simply subtract the exponent, which is the exponent of the numerator minus the exponent of the denominator. For example, if you have 2 to the power 8 by 2 to the power 3, so this becomes 2 to the power 5. Of course, over here a not equal to 0. Now look at the third one, which says the product of two factors raised to the power m. When we simplify it, it becomes a to the power m multiplied by b to the power m. The exponent goes to each and every factor. What do I mean? For example, you have 3x to the power, suppose 5. So this simplifies, gives us 3 to the power 5 multiplied by x to the power 5. Now look at the fourth one, which says a by b whole to the power m is equal to a to the power m divided by b to the power m, which means something like, suppose you have 4 by x to the power 5. This, when you simplify it, becomes 4 to the power 5 by x to the power 5. In this case, a real number raised to the power exponent, which in turn, now look at number 5. In this case, a power raised to another power. When you simplify this, the power gets multiplied. Okay, which means something like you have, suppose 2 to the power 5 to the power 3. An exponent is raised to another exponent. Okay, so this becomes 2 to the power 15. This one, suppose you have a to the power minus m. Now, as I told you, exponent cannot be negative. So how to make it positive? A to the minus m is nothing but the multiplicative inverse of a raised to the power m. So it becomes 1 by a to the power m. At times we can write it as 1 by a to the power m. For example, if you have x to the power minus 3, this will become 1 by x cube. Now we look at some more properties which are there. Number 7, anything to the power 0 is 1, provided the base is not 0. How come this? Just see this one. If I write 2 cube by 2 cube, this is 2 multiplied by 2 multiplied by 2, 2 multiplied by 2 multiplied by 2, which ultimately gives 1. Or we can write this as 2 to the power 3 minus 3, that's 2 to the power 0, which means 2 to the power 0 is nothing but 1, which means if the base, any base provided is not equal to 0, raised to the power 0 is 1. Now look at this one. Qth root of x to the power p is equal to x to the power p by q, where p denotes the index and q denotes the root. What I mean, just look over here. If I have cube root of x square, this can be written as x to the power 2 by 3. Clear? Now look at this one. If we get an equation and on left hand side and on right hand side we have the same base, so we can conclude with certain exponent, then we can conclude that if the bases are same and a single base, then the powers are also same. For example, if 2 to the power 5 is equal to 2 to the power x, simply we can say 5 equals to x. Done. Again, in an equation, if you have single base on both sides, LHS and RHS of the equation, and the powers are same, then we can say the bases are same. What do I mean? Just look over here. If I've got 2 cube equals to x plus 3 whole cube, so we can say that 2 equals to x plus 3. See the single base on both sides and the exponent is same, we can say that the bases are also same. 2 to the power x equals to 2 to the power 5, so we can say x equals to 5 directly. Okay, now one thing remember, minus x whole to the power m, and if m is even, then it becomes plus x to the power m. How come? Look over here. If you have minus 2 to the power 4, this becomes 2 to the power 4, because we know the power, the exponent is both on the negative sign as well as 2. So negative sign repeated 4 times gives you positive sign, and 2 to the power 4 as it is, which is equal to 16. See, it's a positive number. But if you do minus 2 to the power 3, when it is odd, then the minus sign remains and it becomes minus 2 whole cube, that's minus 8, because minus repeated 3 times gives you negative sign only. Now we'll look at some numericals from the chapter. Now let us look at sum number 1 part 2. It's exercise 8 from AGGARWAL. Now they've told us to find the value of this. Now this, if you see, can be written as, this is 125 by 64 whole to the power minus 2 by 3. Now the power is negative. How to make it positive? This becomes a multiplicative inverse. So this becomes 64 by 125 whole to the power 2 by 3. Now whenever the power is in fractional form, try to represent the base as a power of something. What do I mean? 64. Now 64 I can write 4 cube. Similarly 125 I can write 5 cube. Isn't it? Now by this property, the power multiplies. So 3 into 2 by 3, 5, 3 into 2 by 3, that cancels out. So 4 square 16, 5 square is 25. Now look at the next sum. Now look at sum number 3 part 1. They told us to simplify this. Okay. Now x to the power minus 1 I can write 1 by x multiplied by y to the power minus 1 means 1 by y. Whole thing divided by, now x to the power minus 1 is 1 by x plus 1 by y, which is equal to 1 by xy divided by, if we take xy, so y goes over there and x over here. Now if you look carefully, we can cancel the denominator. So it becomes 1 by x plus y. So that's my answer. Now we look at the next sum. Now look at 7 part 2. Simplify this. The dot denotes multiplication. Now look carefully. Can I write 5 multiplied by 25? I can write 5 square whole to the power n plus 1 minus this. I can write a bit like 25. This 5 to the power 2n. Similarly, this becomes 5 multiplied by 5 to the power 2n plus 3 minus this we can write as 5 square n plus 1. Now the power gets multiplied over here. So this becomes 5 multiplied by 5 to the power 2n plus 2 minus 25 into 5 to the power 2n by 5 into 5 to the power 2n plus 3 minus 5 to the power 2n plus 2. Now look carefully this one. A to the power m plus n is nothing but a to the power m multiplied by a to the power n. Similarly, this we can write as 5 to the power 2n multiplied by 5 square, isn't it? And in the denominator also can we write this one as 5 to the power 2n. This is 5 cube. This is 5 to the power 2n 5 square. Now look carefully. If you take 5 to the power 2n common, so what is left? 5 square and 5, that's 25 into 5 is 125 is left over here, and 25 is left over here. Similarly, if you take 5 to the power 2n common, so 5 cube is 125 into 5, 625 is left over here. 5 square means 25 is left over here. So this is what? This is 5 to the power 2n. Bases are same. You can subtract the power. This becomes 100, and over here it is 600, isn't it? Now this becomes 5 to the power 0. This becomes 1 by 6. 5 to the power 0 is 1. So 1 into 1 by 6 is 1 by 6. And that's my answer. Now we look at the next sum. You can pause the video and see the sum. Now look at this sum. 8 part 2. Simplify this. Now we can write this as 3 cube, and 8 we can write 2 cube whole to the power 2 by 3 minus. Now the power is negative, so this becomes a multiplicative inverse of 4 to the power 2 plus something to the power 0 is 1. Now when you open the bracket, 3 multiplied by 2 by 3, 2 cube multiplied by 2 by 3 minus 16 plus 1. So this cancels out. 3 square is 9, and this is how much? 4. This is minus 15. So 4 taken LCM, 9 minus 60, that's minus 51 by 4. And that's your answer. Am I correct? Now we look at the next sum. Now look at 11 part 2. They told us to simplify this. Now 81 to the power 3 by 4. 81 can be written as 3 to the power 4. So this is 3 to the power 4, 3 by 4 minus, this becomes a multiplicative inverse because the power is negative. So this becomes 32 to the power 2 by 5. Now 8 can be written as 2 cube. Again, this becomes a multiplicative inverse. So this becomes 2 to the power 1, and something to the power 0 is 1. Now this becomes 3 cube is 27 minus, this we can write as 2 to the power 5. 2 by 5, this 3 cancels out, so 2 multiplied by 2 multiplied by 1. So over here this and this cancels out, so this is 27 minus 4 plus 4, that's 27. You can pause the video and see the sum. Now look at this sum. Okay, simplify. Now first of all, we'll make the power positive. How? This becomes the inverse, multiplicative inverse, which is nothing but this. Actually, if we change division to multiplication, this becomes a reciprocal, which means the numerator becomes a denominator. So 256 by 625 to the power 1 by 4 by 1. We are not writing 1. And something to the power 0 is 1 always. Now to 125 I can write 5 cube. This I can write 4 cube to the power 2 by 3 multiplied by this I can write 4 to the power 4. This I can write 5 to the power 4, 1 by 4 plus 1. And when you simplify this becomes 5 cube into 2 by 3, 4 cube multiplied by 2 by 3. Similarly over here it becomes 4 to the power 4 into 1 by 4, 5 to the power 4 into 1 by 4 plus 1. Now this cancels out. So what is left? 5 square, which is 25. 4 square is 16. 4 by 5 plus 1. This 4 1. 4 4 times. 5 1. 5 5 times. So this becomes 5 by 4 plus 1. When you add it, it becomes 9 by 4. And that's my answer. Clear? You can pause the video and copy this sum. Now look at this sum. They've told us to simplify this. Now 5 to the power n plus 3 can be written as 5 to the power n multiplied by 5 cube by this. X to the power m plus 1 can be written as x to the power m multiplied by x to the power n. Similarly, over here I can write 5 to the power n multiplied by 5 to the power 1, or 5 is same thing. This is 9 into 5 to the power n minus this is 4 into 5 to the power n. Now if you look carefully, if you take out 5 to the power n common, this is 5 cube minus 6 5s are 30 is left over here. Similarly in the denominator, if you take 5 to the power n common, 9 minus 4 is left, which is equal to, base is the same, we can subtract the power, and 5 cube is 125 minus 30 by 9 minus 4 is 5. Now this becomes 5 to the power 0 is 1, and 125 minus 30 is 95 by 5, which is equal to 90. And that's my answer. Clear? Now look at sum number 17 part 1. Simplify this. Now if you carefully closely look at this, a minus b, and this is a plus b in that form. So the power is there 1 by 3 on both. If you look at this property, x to the power m and y to the power n can be written as xy to the power n, which means this can be written as root 32 minus root 5 root 32 plus root 5 whole to the power 1 by 3. Now this is in the form of a minus b, a plus b, which is a square minus b square. This is raised to the power 1 by 3. Now this is 32 minus 5, 1 by 3. That is equal to 27 to the power 1 by 3. We know 27 is 3 cube into 1 by 3, that's 3. Because this cancels out. So that's my answer. Now look at this sum. Simplify this. Now we know if base is the same, you can subtract the power. So this is same over here, n minus l to the power m, same minus over here. Now when you simplify this, the power gets multiplied, so this becomes x to the power ml minus nl multiplied by x to the power nm minus lm multiplied by x to the power ln minus mn. Now bases are same, we can simply add the power, ml minus nl plus nm minus lm plus ln minus mn. Now if you look carefully, I think this cancels out, this and this and this, so we are left with x to the power 0, and that is nothing but 1. Now look at 19 part 1, which says us to simplify this. Now look, if we simplify this, look at this, kth root to the power x to the power p becomes x to the power p by q. Similarly, this will become x to the power L by x to the power M to the power L 1 by Lm. Similarly, this becomes x to the power M by x to the power N 1 by Mn power, and this becomes x to the power N by x to the power L, and power is 1 by Nn. Now when you open the bracket, the power goes to the numerator as well as the denominator, so this becomes x to the power L into 1 by Lm, x to the power M into 1 by Lm. Similarly, this becomes x to the power M into 1 by Mn, x to the power N into 1 by Mn. Similarly, this is x to the power N into 1 by Nl, and this is x to the power L into 1 by Nl. Now if you solve this, I think we are getting something like, over here you will get x to the power 1 by M by x to the power 1 by L multiplied by x to the power 1 by N, x to the power 1 by M multiplied by x to the power 1 by L, x to the power 1 by M. Now bases are same. In one step I am writing, see, in case of multiplication you add the power, in case of division you subtract the power. In one step only I am doing, okay. See, the power cancels out and becomes x power 0, which is equal to 1. Clear? Now look at 19 part 3. Simplify this. Now if we know that the bases are same, in case of division the powers are subtracted. Now a minus of minus b ultimately becomes a plus b, isn't it? Which means I can write this as x to the power a plus b, and this is a square minus ab plus b square as it is. Similarly, this becomes x to the power b plus c, and the power is b square minus bc plus c square. Similarly, this becomes x to the power c plus a. This is c square plus minus ac plus a square. Now if you look carefully, a plus b multiplied by a square minus ab plus b square is equal to a cube plus b cube. Factorization we have done, okay. So this becomes x to the power a cube minus b cube. This becomes x to the power b cube minus c cube. This becomes x to the power c cube minus a cube. Now the bases are same, we can add the power, so this becomes x to the power a cube minus b cube plus b cube minus c cube plus c cube minus a cube. I think all the power cancels out, so x was 0, and that's 1. Clear? Now look at this sum, a very interesting sum. If a equals to c to the power z, b equals to a to the power x, and c equals to b to the power y, prove that x, y, z equals to 1. Let's see how to proceed. A equals to c to the power z, which implies a equals to, now in place of c, can I write b to the power y? Isn't it? So this becomes a equals to b to the power yz. Now similarly, in case of b, can I write a to the power x? So this becomes a equals to a to the power x, y, z. A means a to the power 1. Now bases are same. We know that the powers are also equal, which means x, y, z equals to 1. Proved. Done. Now look at sum number 24. 2 to the power x. If 2 to the power x equals to 3 to the power y equals to 6 to the power minus z, prove that 1 by x equals plus 1 by y plus 1 by z equals to 0. Now look carefully. What is given to us? 2 to the power x equals to 3 to the power y equals to 6 to the power minus z. Suppose I take this as k. Then I can write, equating this and this, 2 equals to k to the power 1 by x. Okay, equating this and this, I can write 3 equals to k to the power 1 by y. And equating these two, we can write 6 equals to k to the power minus 1 by z. Am I clear? Now look carefully. We can write 2 multiplied by 3 equals to 6. In case of 2, we can write k to the power 1 by x, k to the power 1 by y equals to k to the power minus 1 by z. Our base is the same, you add the power, 1 by x plus 1 by y equals to k to the power minus 1 by z, which means if the base is the same, the powers are equal, we can say. So 1 by x plus 1 by y equals to minus 1 by z, which means 1 by x plus 1 by y plus 1 by z equals to 0. True. Done. Now look at 34 part 3, where this said solve for x and they're given an equation. Now we know that if bases are same on both sides, then you can equate the power, and our unknown variable is the power only, so we'll try to use that. Now this square root can be written as 3 by 5 to the power half, isn't it? And this can be written as 5 by 3 whole cube, if you see. Now this is 3 by 5 to the power half multiplied by x plus 1 will be x plus 1 by 2. Actually, this 5 by 3 to the 3 can be write as 3 by 5 to the power minus 3, isn't it? Which means now see, base is the same, just equate the power, which means x plus 1 equals to minus 6 or x equals to minus 7. And that's my answer. Now look at sum number 35 part 1. Again, solve for x. We will use the same logic, that if the base is the same, the powers are equal. Now this we can write p by q to the power half, and this, if we write the multiplicative inverse, we know the sign changes, so this becomes 2x minus 1. Now if the base is the same, so we can equate the power, that is half equals to 2x minus 1, or half plus 1 equals to 2x. This is 3 by 2 equals to 2x, which means 3 by 4 equals to x. And that's my answer. Now look at sum number 37, a very nice sum. They've given a situation and they've told that prove that m equals to 1 plus n. Similarly, if you look over here, the variables m and n are in the power. So we need to use the same logic, that if bases are same, the powers are equal. Now look over here. This 9 I can write 3 square. This is 3 square, this is 3 to the power n minus, and this is 3 cube. Am I clear? So this is 3 to the power 3m. This is 8. This is 1 by 27. Now look over here, this is 3 to the power 2n, 3 square, 3 to the power n, minus 3 to the power 3n. This is 3 to the power 3m into 8 equals to 1 by 27. Now look carefully, this and this, though the bases are same in all the three, I use this only, you know. So 3 to the power 2n and 3 to the power n becomes 3 to the power 3n multiplied by 3 square minus 3 to the power 3n by 3 to the power 3m to 8 equals to 1 by 27. Now look carefully, if I take 3 to the power 3n common, what is left? 3 square, which is 9, minus 1 in the denominator equals to, I can write this as 1 by 3 whole cube, which means, look carefully, this becomes 3 to the power, bases are same, we can subtract the power, 3n minus 3m, and 9 minus 1 is 8, 8 by 8, so that's 8 by 8 equals to, and this becomes, I can write this as 3 to the power minus 3. Any issue? Now we solve this, this cancels out, and so this becomes 3 to the power 3n minus 3n equals to 3 or minus 3. Now bases are same, we can equate the power, so 3n minus 3m equals to minus 3, 3 taken common, n minus m equals to minus 1, so n plus 1 equals to n. That was to be proved. Done. Now look at sum number 40 part 1. They've given an equation and they've told us to solve for x. Now look over here. Can we write this as 2 to the power x plus 1 minus 2 to the power x multiplied by 2 to the power 2 plus 5 equals to 0. Now let 2 to the power x equals to a. So how does it helps us? 3a plus 1 minus 2 square is 4, 4a plus 5 equals to 0, which means 3a plus 3 minus 4a plus 5 equals to 0, which means minus a plus 8 equals to 0, which means minus a equals to minus 8, which means a equals to 8. Now what was a? A was 2 to the power x equals to 8, which means 2 to the power x equals to 2 cube, which simply means x equals to 3, and that's my answer. Now we look at the last sum. Now look at the last sum for this chapter. They've given 3 to the power x equals to 9 multiplied, this dot denotes multiply, by into 3 to the power y, and second equation they have given 8 multiplied by 2 to the power y equals to 4 to the power x. Now we have two unknowns x and y, we'll get two equations which will simplify. First of all, look over here. This can be written as 3 to the power x equals to 3 square multiplied by 3 to the power y, which means we can say 3 to the power x equals to 3 to the power 2 plus y, which means I can say x equals to 2 plus y. Done. Now look at this. We know the bases are same, the powers are same. Now this we can be 2 cube multiplied by 2 to the power y equals to, this will be 2 to the power 2x, because 4 can be written as 2 square and the power gets multiplied, 2 into x is 2x, so this can be written as 2 to the power 3 plus y equals to 2 to the power 2x, which means 3 plus y equals to 2x. Am I clear? Now we have two equations, we'll solve it. See, if I take out the value of y and put it over here, can I write x minus 2 equals to y? So over here, if I put the value, so 3 plus, instead of y I can write x minus 2 equals to 2x, which means 3 minus 2 equals to 2x minus 2, 2x minus x, sorry, which means 1 equals to x. So the value of x is 1. Now put over here and get the value of y. We have x minus 2 equals to y, or 1 minus 2 equals to y, which means minus 1 equals to y. That is x equals to 1 and y equals to minus 1. Clear?